I'm working for Abstract since 2K8. I'm a front-end and back-end developer. I'm working Plone, Django, and other framework. Since July, I'm working on a Plone site of EEA with a collaborative project with Abstract and How the Web. So, the main site of EEA has about 30,000 page views per day, 30 editors per day, which 10 simultaneous. I have 7 servers, 2 front-end, and 5 back-end. We use REST. The problem is how to monitor this infrastructure. The EEA solution is use 2 kinds of tools. Traceview to monitor layers of application, and control panel to control the real time what users do. Traceview is provide code level performance. Monitor web application is developed by Epnata. The important features is a full stack monitor. We have possibility to introspect all application level, hardware, DB, backend, and front-end. You can identify a bottleneck and a quick overview over layer. To use it in Zoop, Plone, we need have egg collected Traceview. To add other layer to application. It add a Zoop HTTP server, Zoop publisher, ZooDB, portal transfers, and other. You can see it. So this is, oops, sorry. The demo. Start demo. Okay. So this Traceview EEA. We can view the tracking of error of application, and investigate on the filters of rules, every layer. We will from Traceview collect Traceview, partition, controllers, and find errors where we go. For example, you can find errors in the layer, and we can investigate to the errors. And find where is it located. We can introspect into code, and we find the query is got in error. Yes. No calls, first occurrence. So, where is it? This is the query. So, back to trade. We call the stack, called stack, in error. But later to presentation. That the stack of error or a possibility error in PyBlib METC, the possibility error of a breakdown of the application, and sorry. The next tool is used to monitor which users are logged in and what you do is EEA control panel. We have two principal panels. One panel is used to view is the login user, and you can identify which user is the real activate and he is not active with a different marker. Tool blue point is for active, empty for not active. The active full is fine, will work for via JavaScript. The main feature of EEA control panel is the auto refresh. The data is saved and kept via Python logger. It's safe portal is most important when during upgrades because it allows to know if there are user active. There is an active user and what they are doing in platform before update. Now I show you the tools we can use to control the log generated by portal. Plone save log in a file, and when it increases, it's most difficult to find errors, and it's most difficult to maintain a history of these errors. A beautiful way to manage log is to use Graylog. Graylog is a fully integrated open source log for collecting, indexing, and unstructured data from all master users. This is open source and is a pluggable. With the Graylog collector can forward data from any log source and support flexible input types including syslog, plain text, gelf, and other else. Graylog extractor and grok partners and they'll identify valuable information contained in a grok. The most important overlay Graylog is the real-time processing. Graylog streams supplier rules in real time to find specific message conditions. Another feature is a dashboard. Any analyzer source user can be added as a widget to a dashboard. Keep all your important data trending in place. Graylog can be installed in many different ways. The virtual implies the web and the RPM package, Chef, Puppet, Ansible, Vagrant, and manual installation. In EEA, you use Docker to install it. Docker is an awesome tool can use to deploy a production system. It allows you to isolate your code in a completely clean system environment. The Docker is a sort of installation recipe that can be used to initialize a system environment. To understand Docker, you need to know about 3 components: Docker image, Docker registers, and Docker containers. Docker image is a read-only template. For example, an image could contain an Ubuntu operating system, or an Apache, Docker registers all the images, and Docker containers are similar to a directory. A Docker container holds everything that is needed for an application to run. Each container is created from a Docker image. Docker containers can be run, started, stopped, moved, and delete. Each container is an isolated and secure application platform. Docker is a perfect helping with the development life cycle. Allow the developers to develop on local containers that contains your application and service, and the same in the same environment used to staging, production, and reels. Docker containers-based platform is a lightweight nature, and also make a dynamically managed workplace easy. You can use Docker to quickly scale up or tear down application and service. In EEA Docker, you have create an image for Docker, Docker Graylog 2. In one system to set up this the Graylog Docker. The Docker file we can view the Docker file. This is a Docker file. This install everything is used to set up it. Elasticsearch, MongoDB to save data, and all the rest. It's use TCP UDP protocol. In this example, you use UDP. You have create a Docker image to Docker app. And you can use it to set up of Graylog. To use Graylog into Plone, we have used integrator PX. This is a Graylogger sorry. Graylogger is a tool to integrate Plone and Zoplog into Graylog to create a log centralized use. To start Graylog, it's app.shift-g. Graylog is based on GrayPy, send messaging via Jelf. Graylog extended login format. It can be set the message using MPQ, Advanced Message Query Protocol, with RabbitMQ. Message sent via UD protocol. To a Docker, with a Docker Graylog, you make a log central. Make with Docker Compose. It's created by different layer, Web, Fluent, Graylog, Rabbit, and Q. And these all in setup to start a Graylog central, unlock central view system. In most futures is UDP and TCP protocol. You have an LDP integration. You can use Gelf, Rabbit, MQ, and syslog to send message to Graylog. And this work with and without Plone. It is a generic solution for logging. And now you can see your logs. A centrally used log. Yeah. Find there's no error in here. Oh, okay. We can view this as a various log in Graylog. And it's the timestamp to log is generated. The server, it generated this error, the message. You can filter with other important information. With look at the PID, the processor generated this error, this log. And we can view the streams of information. Or any dashboard used to manage the logger in EEA. It's no error. No error. I'm not going to film it. Error. Sorry for the time. It's end the presentation. Every question will. Stop it.
Could you compare this Graylog to Sentry? Do you know what is better or?
We are using internally Sentry as a logger, a centralized logger. So I just wonder if you can compare these two tools.
This is only case study. We not I will not compare it with other systems. We use it for it is simple to install and is pluggable with Pythons and other systems. We use it not only in Plone but in PHP or other systems. And any questions?
We are using Sentry on ODWeb on different projects, not only on ZOP projects or Plone projects, Python or PHP projects. And the power of Sentry is that you receive the error immediately. That's the main issue. You can go directly to see it happened now, and I react now. So it's better than Graylog for reactions. But on a long term, when you want to make statistics in what happened in your site during 1 month or 2 months, it's the Graylog is better. You can see. And for EEA and for Plone and for this architecture, the Traceview was a lot better than Sentry. It is more powerful, and you see exactly what ZOP instance had the error, what in what request, and everything. Sentry is a lot basic, more basic than. But Traceview is not open source; it's on money. It's Sentry is open source, Graylog is open source, but Traceview costs. I don't know exactly how much, but it's not the cheapest solution. Yeah.
Is there any questions? If I ended the presentation, sorry.
Actually, I have two. Did I saw it right? Why do you use Docker Compose on a production server? And the second thing, how you then you have all the Docker containers running. How you actually then monitor your Docker containers?
I understand. I don't understand.
Okay. Why you're using Docker Compose on a production server and not hooking it up into, for example, systemd to start the process and monitor this process with Docker? And then how you monitor your containers?
I don't understand the question.
He asked why do you monitor the why are you using Docker Compose instead of system starting services process like systemd from modern Linuxes?
I don't understand. I don't speak English.
I can't respond on this particular case, but I think it's easier to have a programmer tool, not a system administrator tool like systemd. With Docker Compose, I don't think you require root access, but with systemd, sure, you need root access. I know that other colleagues of us are using supervisor for the exact same reason. They put the build out, they create the supervisor. Do you familiar with the supervisor? Okay, and they are using everything at user level.
That then means you run your containers not as root but as user on the server.
It's a lot safer.
Okay.
It's a lot safer to run any application on your servers, to run them as user, not as root.
And thank you.